So in this video, we are going to talk about string slices and the slice type in general. So basically in Rush, there are three types of strings: the basic string type, then there are something called as string literals and string slices. We'll talk about each of those in much detail in this video. So let's get started. So yeah, the slice type. So basically slices let you reference a contiguous sequence of elements in any collection rather than the whole collection itself. And a slice is a kind of a reference, so you actually don't own the value, you just have a reference to it. So yeah, it does not have ownership. So let's understand that in detail, but for that let's look at an example. Let me define a string. So s is a string, and I'll make it equal to string from the literal hello world. Yeah, something like this. Yeah, so let me save it. Yeah, as you can see, I have declared a variable s, which is nothing but of the string type, and it is made from the literal hello world. So right now the type of s is string. As you can see, when I hover over it, VS Code tells me that the type of s is string, and I've also annotated over here, explicitly mentioned the type of s. But if I hover over hello world, then as you can see, the type of hello world is at str, which is nothing but a string literal type. As you can see, VS Code is telling me over here that the value of this literal is hello world. So what is the difference between a string type and an at str type, and then what are string slices? Now let's look at that. Now to understand, in order to understand that, let's take a example. Let's say if we want to find the first word in any string. Now the string that I have taken over here is hello world. Now let's say I want to write a function that just returns me the first word inside the string, which is hello in this case. Now how would I do that? Now if you have any programming experience, you know that the easiest way to do that is iterate over the string and then just find the first blank space. Now the moment we encounter the first blank space, we just return everything before it. No, that would be basically the first word inside the string. Now let's see two different approaches to do that, and then which approach is better, we'll discuss on that, and through that we'll understand what string slices are and why they are important. So yeah, I've taken a function over here, fn, the keyword to declare a function, and the name of the function first word. Now it takes a parameter s, which is nothing but a reference to a string. We want to iterate over a string, so yeah, we are taking a string reference as a parameter, not the ownership of the string. Yeah, and then it just returns a u size, which is the type of a number. Now inside the function body, what we are doing is we are declaring a variable bytes, which is nothing but s dot as bytes. Now what the as bytes method does is it just converts the value which we provided into a sequence of bytes. So over here it will convert the string into a sequence of bytes, and then we are just running a for loop in which we are running the for loop on bytes dot iter dot enumerate. Now let's understand this one by one. Now the bytes dot iter, the dot iter method will just return iterator. Now iterators in Rust are a very detailed topic. We'll talk about that in some later video. But what the dot iter method does is it returns a iterator. Iterators can be of different types. We'll talk about that later. But for right now, just understand that the dot iter method will return an iterator, and with the help of that iterator, we will be able to iterate on each and every byte in the bytes that we have in the bytes variable. And then the dot enumerate method will return us a tuple, in that the first element will be the index and the second element will be the reference to that particular item, to that particular byte. So yeah, we have destructured that over here, as you can see. And then inside the for loop, we are just checking if that item, if that particular byte value is equal to a blank space. Now we have used the byte literal syntax. We'll talk about these in a later video, but yeah, this is the syntax for a byte literal. And we are checking that if that item is actually equal to a blank space byte. And if it is, then we are returning that index, because that will be our first blank space in the string and everything before it will be our first word, in this case hello. And if we don't encounter a blank space byte, then we just return the length of the string, because then there are no blank spaces in our string, which means that our string is basically just one whole word. Now this is the first approach in which we are doing it with the help of indexes, but this has a drawback. Now let us understand what that drawback is and what that fault is and why this method is not so good, and why we introduce string slices for that in order to correct it. So yeah, inside the main function, we are just declaring a mutable variable s, which is nothing but string from the literal hello world, and then we are declaring a variable word, and we are binding it to the return of our first word function. And yeah, we are just passing a reference, immutable reference to the string. And yeah, once we do that, we'll get the index value returned in our word. This function call will actually return us the index value where that first blank space was, because that is what our first word function is doing over here. And so yeah, we, let's say the first blank space is at the index 5, then the word variable over here will contain the value 5. But then I call the dot clear function on s. Now s is a mutable variable, so we can mutate it. So when we call the dot clear function on s, what it does, it just empties the string. So now we had hello world in the string s, but then we called a dot clear method. So now there is nothing inside the string s, but our variable word still contains the index 5. Now this is incorrect, because now basically our our word variable shouldn't contain anything, because there is technically no word inside the string s. So in order to fix this, we introduce string slices. Now first let us understand this problem in even detail. So yeah, initially I declared a variable s, which was of type string, and it was pointing to a string in the heap, which was something like this: hello world. And then I iterated over the string inside this function, and returned the index of the first blank space. So that would be 5, and it would just mean that the first word is hello and it is ending at the index 5. But then I called a dot clear function. Now the dot clear function would just delete this entire string from the heap, but the word variable would still contain the index 5, which is wrong, because now it should contain basically nothing, because we don't have any string in the first place, because we cleared it using the dot clear method call. So this is what the problem is, which string slices solve. Because after this, in the program, if anywhere I use the word variable, it would not give me a desired output, because it would give me a incorrect output basically, because the word variable thinks that the first blank space is at index 5, but we just cleared the string after that, so there is practically nothing inside the string. So this is the problem that string slices solve. Now let us understand how they do it. So a string slice is just a reference to a part of the string. Let's say if I had a string s, which is pointing to this value on heap, which is hello world, and I want a reference to the second part of the string, which is just the second word of the string, the world word. Now a string slice would be just a reference pointing to the starting index of this second part, the world. Now this is how string slices solve the problem. They don't actually give you an index or the ownership of the value. They just refer to the value and give you a view inside the string. So now even if after I clear the string from the heap, then the string slice would actually prevent me from doing it if I have a reference inside it. And if I don't have a valid reference inside it, you can just go ahead and clear it, and then the string slice would refer to just nothing. So this solves a problem. And in the future, if you refer to the string slice in your code, then it would just refer to nothing. So you don't have a dangling reference inside memory. Now if you don't know dangling references, I highly recommend you to watch the first video, because in that I've explained what dangling references are. So basically string slices would prevent that from happening, because if you clear the string, then first case would be that your string slice reference won't allow you to do that. And if you no longer have a reference, then you can go ahead and clear the string, because then the reference would basically be pointing to nothing on the heap. Yeah. So yeah, then let us understand this code snippet over here. We are declaring a variable s, which is nothing but string from the literal hello. So now s is of type string, and it is pointing to a value hello world on the heap. And yeah, we can, if you're from a programming language like Python, you must be knowing this syntax. So we are just declaring a variable hello, which is nothing but a reference to s, and inside s it is particularly a reference to from the 0th index to the 5th index, which is the word hello. And then we are declaring a variable world, which is nothing but a reference inside s from the 6th index to the 11th index. So they are not referring to the entire collection, to the entire string hello world. They are just referencing to a part of it. And because they are just referencing and not owning the actual value, or not returning the index, when we clear the string s or mutate it in future, these values will change accordingly. And yeah, so we won't have an invalid value later on in the program if we do changes to the string s. So that is what basically string literals are and how they solve this problem. Now, yeah, this was a previous code, as you can see, and we have just made a bit change. That is, instead of returning the index of the first blank space, we are returning a reference to a string, which is the string slice. So let us see what this function is doing. We are accepting a reference to a string as the parameter s, and then we are returning a string slice. And then inside the function body we are declaring a variable bytes, which is nothing but again s dot as bytes. This will return a sequence of bytes. And then in the for loop we are iterating through those bytes using the bytes dot iter dot enumerate. Now I explained what this does. The dot iter will return an iterator which will help us in iterating, and the dot enumerate method will return a tuple in which the first value will be an index, and the second value would be the reference to that actual byte, to that actual item inside our collection on which we are iterating. And inside the for loop there is an if statement, and we are checking if the item is equal to a blank space. Then we are returning a reference inside that string from the 0th index to the ith index, so that is going to be a first word. And then we are just returning this reference. Now there is one more thing that we need to keep in mind while using such functions and doing such programming is there is something called as lifetimes in Rust. Now you have to make sure that your reference will be valid. Let's say your reference is going to be valid till a certain point inside your code, then you have to make sure that your string is also valid till that point. Because if your string goes out of scope before that, then your reference would no longer be valid. So this is something called as the lifetime problem, and we'll go into it in much detail in further videos when we actually discuss the concept of lifetime. It is a much difficult concept, but we'll break it down into simpler parts. So yeah, we have to take care of lifetimes over here. And yeah, you don't need to worry about what lifetimes are right now. We'll look into that later. So this is how we solve the problem which we were encountering previously, that if I change the string s, then our index would be invalid, the index that we returned using the first word function, which is not a good way to do that. But yeah, if your value is not mutable, then you can use that approach, because then s won't change. Like, it might go out of scope, but then the word variable can also go out of scope at the same time, so that would prevent any future errors. But yeah, if your string is mutable, then it is better that you return a reference inside that string instead of returning the first index where the first word ends. So this is a better approach. Now yeah, let us see what we are doing inside the main function. We are declaring a mutable variable s, which is nothing but string from the literal hello world, and then we are passing the reference to the string inside a first word function and binding its return to the word variable. And if we now try to clear the string s, it won't actually let us do that. Why? Because then word is a valid reference inside the string s. And if we try to clear s, then it would Rust will basically tell us that you cannot do this, because we still have a reference inside that string. Now the reference has to go out of scope or become invalid, then we can actually mutate the string or change the string or clear it. So let's try to run this code and see what error Rust is giving us. So first let me comment the previous code, and let us write our first word function, fn first underscore word. It is taking a parameter s which is of the type reference to a string, and then just returning a string slice or a it is not a string literal, but both string literal and string slices are denoted by the same type at str, but this is a string slice that we are returning, not a string literal. So yeah, at str is the return type, and then inside the function body we are declaring a variable let bytes, which is equal to s dot as bytes. Yeah, and then we are running a for loop. Now we are destructuring the return of the dot enumerate method in the index and the reference to that item. at item, yeah, in bytes dot iter, which returns an iterator dot enumerate, yeah. And then inside this for loop we are checking if our item equal a blank space, then we return that index, or rather a string slice till that index, return a slice into s starting from the 0th index and going on till the ith index. And if we don't encounter a blank space, then we just return the entire string itself, because then it would be just one complete word. Yeah. And to return the entire string, we just don't need to specify the starting and ending indexes. We just need to put two dots. So that means the we are referring to the entire string from the starting index to the last index. Yeah, so this is our first word function. And now inside the main function, let us actually call this first word function. So I'll declare a mutable string s, which is equal to string colon colon from the literal hello world. And then I am declaring a variable word, which is going to be a first word, and I'm making it equal to the return of the first word function. Yeah, and inside it I'm passing a reference to my string. I'm passing a immutable reference to a string. Our string itself is mutable. Yeah, and then I'm trying to clear our string using the s dot clear method, and then I'm trying to print the word that our first word function has returned. Yeah. Now let's try to save this. As you can see, we get a red squiggly line under s dot clear. So Rust is telling us that you cannot do this because your string has a current valid reference inside it. So if you clear the string, then this reference will be, invalid. So you can't do that. You first have to drop this reference and then you will be able to clear it. So let's try to actually run this code and see what error our compiler is giving us. So we'll check the code first using the cargo check command. As you can see, we get an error. Now let's try to read what this error is telling us. It is saying that immutable borrow occurs over here in our first word function call. And after that, we are trying to clear the string. Now, what do we mean by actually trying to clear the string? By using the dot clear method. So our variable s is actually a mutable string. Now, in order to clear it, that would simply mean that we are mutating the string. And in order to mutate the string, we need a mutable reference. So let's actually try to see the source code. Let me control click over clear, and as you can see, the clear method is actually taking a mutable reference to self. And if you know the ownerships of if you know the rules of ownership, you must be knowing that we cannot have a mutable and immutable reference at the same time. So this is what is happening over here. We have actually made a immutable reference to the string s, and then using the s dot clear method, we are trying to make another mutable reference. So this won't happen because due to the rules of ownership, and hence our compiler is complaining that the code you have written won't compile. Now, yeah, this is all about string slices. And there is one more thing known as string literals. Let's talk about this and how it is different from a string slice. So, first, let me comment the previous code. Yeah. And let's see what string slices are. Now, let's first understand this code snippet. I am declaring a variable s and making it equal to the string literal hello world. And if you want to modify the function previous function to accept this value, then the parameter of s would be at str, not a string type or not a reference to a string. It would be at str, which is a string literal type. Now, what is the difference between a string slice and a string literal? See, basically, when you declare a string and when you reference a particular part of that string, that is a string slice, because you're actually slicing that string and referring to a part of it. But what is string literal then? Let's say if let me just first write a main function over here, and let me, declare the variable s, which is equal to the literal hello world. Now, if I hover over, see, VS Code tells me, it infers that the type of S over here is actually at str, which is a string literal. Now, as you know that Rust is a statically typed language. Now, I have written this line of code, S equals the literal hello world. And when I'll be compiling this code, the compiler will already know that I have written this line of code somewhere. So this value is actually hard coded in the binary file that we get when we actually compile our code, and that is what runs when we use the command cargo run. So this actual value, this actual at str means just a reference to a value somewhere. So this is actually a reference inside the binary that will be formed when we compile this code. Now let me just save the file. Yeah. And if you go inside, your file tree and go inside the target folder and inside the debug folder, you will actually have a exe file. Now this is the executable file, this is the actual binary file that runs. So the value of s, which is hello world, is actually hard coded inside this lessons.exe file, inside this binary file. And this s variable is actually a reference into that part inside this executable file. So that is what a string literal is. It is directly hard coded into our binary file. And a string slice is just a reference inside a string. It is just referring to a part of the string. And then there is a string a data type, a string type, which I'm sure you must be familiar by now. So that was all about, strings, string literals, and string slices, and what is the better approach. Should you use indexing or should you use string slices? So you should use string slices because they help you to avoid making any changes. So yeah, that is what we understood in the first example, that if you have an immutable borrow inside a string, immutable reference inside the string, you cannot actually go ahead and mutate it later, because then whatever you were referring to became invalid and it would refer to something else. So we don't want that to happen in our code. That is why we use string slices instead of using indexes, because indexes would create much confusion, and they would actually return as the invalid index if we go ahead and mutate our string later on. So that is why we use string slices over indexing. And that was all about this video. I hope you understood it. If you have not watched our previous videos, I highly recommend watching them, because without understanding those videos, without understanding what ownership is, what references are, what borrowing is, you won't be able to understand these topics. Now in the future videos, I'll be bringing more advanced concepts. Now stay tuned, like the video, share it with your friends if you like it, and consider subscribing so you get updates about our latest videos, and you can follow along and actually learn Rust programming. Thank you everyone. That was all for this video.